Okay, today we'll be learning about the trapezoidal rule. And essentially what the trapezoidal rule is. So remember how in calculus, traditionally we find areas under curves using RRAM, MRAM, or LRAM, which are different ways of using rectangles to approximate the area under a curve as shown here in this drawing. So we can see the use of several rectangles to roughly approximate the area. The problem with using rectangles to approximate area under a curve is that you get an accurate answer as you add more and more rectangles, but it's never quite as close as you might want it to be in some real world applications of finding areas under the curve. So to solve this problem by using a much more accurate method, mathematicians invented the trapezoidal rule. And what the trapezoidal rule does is that it uses trapezoids to approximate area under a curve. And as you can see here, using trapezoids follows the bound of the curve much better and much closer than rectangles do. And this is really powerful and useful in calculus, as you can get a precise and really close answer for an area under a curve without actually integrating an integral. And this is useful as some integrals are straight up impossible to solve. So the formula for trapezoidal rule is given some integral from a to b of some f of x dx, it is approximately equal to the trapezoidal of some n, which that's equal to the change of x divided by 2 multiplied by f of x, f of the first x value plus twice f of the second value plus, let's make this smaller real quick, plus twice f of the third value, and then continue doing that until you get twice f of the n minus 1. And then we end that off with just the last value of the interval. And the change of x is equal to the upper limit of the integral minus the lower limit divided by n. And as you can see, the formula follows a sort of 1-to-1 pattern, which if you memorize that ratio, it'll make memorizing this formula a lot easier. So let's apply this to a real problem. Here we have approximate the integral from 1 to 5 of ln dx divided by x squared using the trapezoidal rule with n equals 4. And we're supposed to round our estimate to 3 decimal places. So essentially how we can do this is the integral from 5 to 1 of ln of x dx divided by x squared would be approximately equal to the fourth trapezoidal of, which is equal to the change of x, which is equal to the upper limit, which is 5 minus 1, the lower limit divided by 4, which is our n value, and we get 1. And so the value in front of the sum will be a half. And then we get multiplied by f of 1 plus 2 f of 2 plus 2 f of 3 plus 2 f of 4 plus f of 5 to end things off without the 2. And if we evaluate this in the calculator, we will get 1/2 0 plus 173 0.122 0.2 0.086 plus 0.064, and that equals to 0.414. And that is our answer. And remember, this is an approximation, but it's a very good one. So try this one on your own, and thanks for watching.